Dear students, now in this video we are going to see the next heat treatment process, that is the normalizing. So dear students, in normalizing we are heating the steel specimen above the upper critical temperature for both the hypo and hyper-eutectoid steels. Please remember, I will draw the eutectoid transformation diagram here. First of all, let us see, it is applicable for what? It is applicable for all low carbon steels, medium carbon steels and high carbon steels. Is applicable to all. If you see this eutectoid transformation, it is 910 degree centigrade, this is 723 and this is 650. This is alpha iron, this is alpha plus gamma, and this is gamma austenite, gamma plus Fe3C, this is alpha plus Fe3C, up to 2% of carbon. This is 100% perlite, 0.8%, and this is 0.025% of carbon. So what just now I told? So in normalizing we are heating the steel specimen 50 degrees centigrade above the upper critical temperature for both, that is hypo and hyper eutectoid steels. If you see, for this is the hypo up to 0.8, this is the hypoeutectoid, 0.8 that is eutectoid point, and above that it is hypereutectoid. We know it well. So the upper critical temperature for the hypoeutectoid steel is nothing but the A3 line. This is the upper critical temperature, and for hypereutectoid steels this ACM line is the upper critical temperature, and of course this line 723 degrees centigrade is what our lower critical temperature, isn't it? So above this line we are heating for 50 degrees centigrade more than this temperature, okay, above these upper critical temperatures for both hypo and hypereutectoid steels. So this is the range actually for normalizing, range of temperature for normalizing. And of course above this all thing is everywhere it is gamma, that is gamma austenite. So when it is heated just 50 degrees centigrade above this upper critical temperature, the component is soaked or hold for the particular amount of time, or that holding time is basically depend upon the section thickness of the object. And when it is soaked with the suitable time period, it is cooled in the air, or it is cooled in still air. So why? So that is the basic difference between annealing and normalizing, dear students. Please remember, in annealing we are cooling that specimen into furnace itself, but here we are taking this out from the furnace and we are keeping in still air to get cooled. Generally the cooling rate in the still air is obtained 50 to 80 degrees centigrade per minute. how much rate, cooling rate we are getting in the normalizing process? 50 degrees centigrade to 80 degrees centigrade for every minute. That will be the temperature drop, that will be the temperature gradient with time, isn't it? So basically, see, when we apply this normalizing process for the low carbon steel, what the things that we are getting? So when we apply this process for the low carbon steels, what the benefits that we can get? Okay, so please see, when this normalizing is applied for the low carbon steel, so there will be increase in the tensile strength of this low carbon steel. There will be refinement of the grains. There will be improving ductility. There is also improvement in yield strength of the low carbon steel. Please remember this. And actually, please remember, when this steel specimen is cooled with this cooling rate 50 to 80 degrees centigrade, the resultant structure is getting as the sorbite. Okay, and this sorbite actually giving the rise in tensile strength and yield strength. Please remember this. So here the resultant जो structure आता है is the sorbite. Please remember this, which will increase the tensile strength and the yield strength of this material. But see, फाइनल आफ्टर कूलिंग जो भी स्ट्रक्चर आपको मिलेगा आफ्टर द नॉर्मलाइजिंग, इट इज द परलाइट. प्लीज रिमेंबर. सो इन जनरल द स्ट्रक्चर दैट यू आर गेटिंग, so this is the heated specimen where we increase what the grain enlargement and residual stresses relieve होते. Then holding, we are having uniformity in the grains, and when cooled in normalizing, what we are getting in the structure, so there are the layer by layer structure of the ferrite and cementite. So one layer of, say this is white color, it will be ferrite, and this stripped column, okay, will be the cementite. This is nothing but what? Ferrite plus cementite is nothing but the perlite, isn't it? This is the perlite. So final microstructure generally in the normalized specimens, we are getting this ferrite. Oh, sorry, perlite. So dear students, so important thing is that when we have the cooling in the still air, so definitely compared to annealing process, we are obtaining here faster cooling rates, which will results into the finer grain size. And as you know that when the grain size is finer, of course the strength and hardness goes on increasing. So compared to the annealed product, the normalized product are having good strength and hardness. Please remember this. So this is the very important information about the normalizing process. Thank you.